So hello everyone, I'm very excited to be here in honor of Women's Day. My name is Lilach, and I'd like to start with a short video that was one of my favorite growing up. So, potato chips. I mean, you gotta love them, right? Don't worry, I'm not here to talk about potato chips today, although they are truly delicious. So this video is part of a series that was my ultimate favorite growing up. It shows how things work, from the potato to the potato chip, to the chips pack, and to the store. It's basically a streamline of integration. Each system's output is the next system's input. If these systems weren't fully integrated, we wouldn't have potato chips, and that would just be sad. So as a young girl, I was super interested and excited about understanding how things work. And this led to me being a grown-up that is really passionate about integrations. That's just how it worked out. So luckily for me, around 4 years ago, I landed in healthcare where integrations are a big part of our day-to-day. I work in a company called Healthy.io. What we do at Healthy.io is take the smartphone camera and turn it into a medical device. These beautiful kits that you see over here get to our patient's doorstep, and where they can open up the kit, and with our app, they get a step-to-step instructions on how to perform a medical test at home. They don't even need to leave the comfort of their own home. During Corona, in the last couple of years, it's become apparent to the world how important it is to make medical care accessible to each and every one of us, no matter where or when. And this is something that we have been believing in Healthy for the last 8 years. It's very important. So one of the most important parts in our test is the test results. When somebody does a medical test, they have results, and these results need to be streamlined live to the doctor or the nurse once the patient has done the test. If we're not able to put our hand into the healthcare system and be fully integrated with them and send the results, our product isn't worth much. This is why integrations are a very big part of our day-to-day at Healthy.io. A little bit more about myself. So as I said, I'm Lilach. I'm originally a backend developer, and for the past 2.5 years, I've been a tech lead, leading our commercial product in the company, our main commercial product, which is urine tests at home. How does it work? I'll take you through a little bit more of our business. Please bear with me. I know it's a bit long, but it will help us understand why integrations are such a big challenge. So you can see a bunch of our partners in this slide. Down below, you can see Maccabi and Clalit, which are Israeli HMOs. Pregnant women all around Israel get our kits delivered to their house. And when they are, when they are nine months pregnant and they have this huge belly, they don't need to try and cram it into a crowded doctor's clinic toilet. They can just do the test at home and feel very comfortable. It's very substantial. So a lot of our partners are B2B, but our main goal, at least in the UK, is B2G, business to government. Around 1.5 years ago, we established a full end-to-end working integration called Mesh with the NHS themselves. And this integration opened the front door to the NHS for us, and actually enabled us to land a very big governmental deal with the NHS themselves. Without the integration, we probably wouldn't have landed this deal. And this deal was very important for our business and for our company. It was a huge step forward. So I know you're probably all thinking, well, integrations, we do them every day as backend developers, as DevOps engineers. What's the big deal? Well, today I came here to talk about integrations that are much like black boxes. They are very, very challenging. And let's understand a bit why. The first thing is, when you're starting a new integration, you want to open up the API docs and start browsing to see what APIs are at your service. Well, sadly in healthcare, that's not really the situation. There usually are no docs at all, and even if there are docs, they are so long and complex, it's really hard to get the gist out of them. Okay, so if we don't have the docs, let's call up the dev on the other side and talk to them and understand how we're going to integrate together. Also here, sadly, this is a huge challenge. Governmental institutes are very hard to get hold of. I'm sure you've all tried to get hold of the tax office or any kind of institute in the past. They really don't answer. And even if they do answer, it takes like 2 weeks or 3 weeks. And I'm in the middle of my integration and I'm trying to run forward. I can't be waiting 2 or 3 weeks every time I need a small answer on something I want to do. The last challenge is outdated tech. As you can imagine, governmental institutes have systems that are quite old and not maintained very well. That leads to very old protocols that are very hard to integrate with. So I didn't come empty-handed today. I have an example and proof. So the mesh integration I was speaking about before, this is an example of a mesh message. It's really hard to make out what's written over here, right? I mean, what's going on here? If we look a bit closely, we can see that there is a patient name here, some kind of test results, but it's still very hard to understand how to compose a message like this. In integrations, it's very, very hard. There's no like manual book. It's very hard to understand what the next step will be. I find that the best way to learn about integrations is from actual live stories. So I'm warning you, this is based on a true story. I'll walk us through our integration with Mesh today, and we'll take it as a case study. And by that, we will be able to build an integration toolbox that next time that you're heading into this black box of integration, you can just pop out your toolbox that we built today, and you can start hacking with confidence. So what is Mesh? Well, it's definitely not this series from the late 80s that my parents loved watching, but it's certainly the first thing that popped into my mind when I heard the name Mesh. Mesh is a messaging protocol. It was written by the NHS themselves in the late 90s, as I said, outdated technologies. And it's basically a mailbox approach. Each entity in a Mesh system has a mailbox. The mailbox has a client that is in charge of pushing and pulling messages, and the Mesh server serves as the mailman and routes the messages between the different mailboxes. So sounds pretty straightforward, right? Well, let me tell you, this was a hard one to tackle. It took us over a year to complete our end-to-end Mesh integration. And let's start talking step by step, talking about the tools and understand what were the big challenges and how we overtook them. So the first thing you want to do when you're starting an integration, you need a key, you need an API token. In modern systems, you can just log into their website and get an API key online. When it comes to healthcare, it's not the situation, and it's good that it isn't. I mean, we wouldn't want anybody to be able to just put their hand into the health systems and get medical results. This is sensitive information and it's private. So in Mesh, we really had to go through a lot of bureaucracy and sign up and do all kinds of things in order to get the keys. But we ended up getting the keys and we were able to log in. Next thing we need is a test environment, some kind of playground where we can probe the API and try and make sense of what the tools that we can use. So also here, this is quite a challenge in healthcare. There is no test environment. We had to actually test on production, which is both risky and also very time consuming. So we were able to get our keys to Mesh, and we set up our own mailbox, and we decided to start sending messages to ourselves from our mailbox and back into our mailbox in order to start understanding if we are up and running. We sent tens or even hundreds of messages and nothing was coming back. We couldn't get a single acknowledgement of a message going through Mesh and coming back into our mailbox. We were getting quite anxious at this part. I mean, what were we going to do? This was something that was very important to the business. Giving up was not an option. And also, you know how us Israelis are. If we see somebody else achieving it, we're like, we can do it as well. So what was our next step? What me and my boss did is actually pack our bags and take the first plane to London, to the UK. And we actually landed in the UK with a cake. This is a really funny story. So we were busy, the next 4 or 5 days, we were busy running around the whole of England, trying to find some friendly face in one of the NHS clinics that knew something about Mesh and could help us out. Our UK team were busy cashing in all of their favors from the last decade or so, trying to get us into these clinics and with the right person. We had this one visit with a very friendly and knowledgeable doctor in the south of England. And the moment we sat down with him, we understood that he knew what he was doing, and he knew his way around Mesh. So when we knew that we wanted to come back there tomorrow and the next day to make progress, we knew that we couldn't come empty-handedly. And this is where our lemon meringue came into action and really took us a long way. Another very fruitful visit was with Stuart, the IT guy. We were down in Sussex, it's so beautiful there, and we were sitting with some doctors, and they really couldn't tell us a lot about Mesh. But in the corner of my eye, I saw Stuart, the IT guy. And we all know we should be best friends with the IT guys. They actually know everything that's going on. So I excused myself. I walked up to Stuart and I was like, hey, Stuart, maybe you can help me out. You get tens and hundreds of mesh messages every day. Let's do some reverse engineering. Let's sit in front of the Black console. Let's look at the messages that are coming in. And reverse engineer will take the message, we'll put in our details, and we'll see how our message goes into your mailbox. Pretty straightforward. We actually did a lot of progress with Stuart that day, and we were really, really nearly there. Well, we were done in the UK, and my real challenge now was hacking my way back into my own house. I left for the UK pretty abruptly, and I left behind my partner with 1-year-old twins and a 3-year-old girl. I mean, if I was instead of her, I would be furious and change the locks. Luckily for me, she is a very forgiving woman. So we were nearly there, and this was a good time before we started implementing to stop for a moment and make sure that if there isn't a better way to get in. Sometimes when you're so busy trying to get in, you take a lot of detours and you take the long way in. And actually, also here, we realized that there is a much better way in. So you remember I said there was a client that was pushing and pulling messages. We all know how clients are very time-consuming and high maintenance. Well, when we were reading the docs, we realized that there was an API that we could connect you directly from our app to the mesh server in order to send our messages. And this actually saved us a good few weeks in implementation. Excuse me. Okay. So we didn't need the client, we told it goodbye, and we proceeded with the API. Now, we were in. We were so excited. Everybody was popping the champagnes. The Israelis were happy. Our UK field team was over the moon. I mean, we achieved the unachievable. We felt like superstars. It was super exciting. I guess nothing else to do here. We can just go to the beach. Well, you know how it goes in startups. Obviously, we didn't go to the beach. And good thing we didn't. Uh-oh. Around a month after our up and running integration, we found out that we had 80 mesh messages that weren't received by the clinic. This means that these are 80 patients that did our test, got results, and we didn't send the results over to the doctor to get further treatment. This is very bad, and it's not a situation we want to be in. Furthermore, it's not that our shiny monitoring tools are the ones that caught the problem. The clinic actually called us up and were like, hey, guys, where are our messages? We can't see any results going in. This is very bad. And this is the part where we realized that integrations are something, when they're up and running, they're something live and ever changing. And it's very, very good to crack into the black box and very important. But actually, a bigger challenge is debugging black boxes in production once you're up and running. I'd like to take a moment to recap the tools that we spoke about that helped us cracking into the black box, and then we can move to our second part of debugging black boxes. So we talked about authentication and playground. We need keys and we need a place to test our API. Then we talked about doing the footwork and going down and sitting with the people and actually interacting with the people. This takes you a long way. After that, we spoke about reverse engineering. Let's see how everybody else is doing it, and let's see what we can do about it. And last but not least, there might be a better way to get in. And just before you start implementing, it's always a good practice to look and see if there's a better way. So we cracked into the black box, but actually now we're sitting there in the dark, and we have to figure out how to turn on the light, how to debug inside black boxes. Let's walk through our 80 messages fiasco and understand from that how we debug black boxes. So we have 80 messages on our hand that weren't received by the clinic. The first thing we want to do is collect all of these failed messages and send them right away so that the test results can get to the doctor and the patients can get further guidance. So in order to find the messages, obviously we wanted to go into the database and try and understand where the failed messages. Look at the data. Sadly, the database data wasn't modeled correctly, and we also had a lot of missing data there, but we'll get to the data later on. For now, we basically needed to look at our screens, look into the logs, look into CSV, archive logs, all kinds of really places that are hard to find the data, and try and find these lost messages. So we lost a couple of nights of good sleep just stressing in order to find these messages. And we finally found them and we sent them over. Okay, so now that we send this message over, we need to try and understand what the problem was so we can fix it. In order to understand what the problem was, I'll take you through step by step, and we'll go a month back to when our integration was just started to be up and running. So it's a few days after the integration is up and running. We're still a bit hungover from the champagne, but we're working and we're good. And we start getting 500 messages from the mesh server, failed messages with status 500. Okay, this means that the mesh server is probably down. I mean, we talked about outdated systems. It's probably the mesh server's fault. It's very easy to blame them. We're good. It's their fault. However, we did see that we're getting these 500 messages when we're trying to resend asynchronously from the code. We're still getting the 500 messages. But if we try to send the message manually a few minutes later, the message is going through. So really, this is a matter of an unstable mesh server. Okay, so what are we going to do? I mean, we're up and running in production. We can't call up the NHS and tell them, listen, folks, we signed a contract with you, but we found a problem. Don't worry. We're 100% on it. We're trying to solve it. Let's put a hold for like a month. We won't send any results in, and we'll call you in a month. No way. The show must go on. That can't happen. We're obligated to the NHS to keep on streamlining patients' results, and so we shall. So this means that we have to split our effort into two. On the one hand, we need to find the source of the problem. We need to send our DevOps engineers, the best ones we have, in order to try and understand what's the network problem between our connection to the mesh server. That's one thing. But on the other hand, we have to keep on going. So we have to find a workaround that will enable us to send messages once they fail. Now, okay, this means that we have to create this workaround. Actually, this leads us to my next tool, backdoors. When you have a mechanism that is failing, you always need some kind of backdoor in order to resend the messages. If we don't have a backdoor, this means that we will send the message manually. Every time we have a failure, a backend developer needs to go to the database, collect the data manually, compose JSON manually, and then send it over to mesh. This is super risky. One human error, and we would be sending the wrong results to the wrong patient. So we really don't want to take this chance. And also, it's very time-consuming and creates a lot of context switches. So our solution was, let's go to our back office app. Let's create some kind of button there that we put in a message ID, and then we send it. And our code regenerates the message and resends it. This is much safer and also reduces the amount of context switches. So that's great. We created a button in the back office. But hey, I'm sure some of you have experienced this kind of time in the startup where business is picking up and suddenly there's a lot of action and production is all over the place. We have tons of alerts to deal with, some are false alarms, some need to be solved by manual work. And basically 50 or 60% of all of the backend developers, all they do all day long is solve alerts. No features are getting done, and also the backend developers are pretty frustrated. And soon, instead of one button in the back office, we have 20 different buttons for 20 different scenarios, and we're busy pushing buttons, and we don't even know what button to select. This is not scalable. We need to find some kind of scalable solution for this situation. Luckily for us, during that time, our company announced a hackathon, and we thought that was the perfect opportunity to solve our problem. We created a bot called Alerty. Alerts plus healthy. Very smart on the time, I know. So what Alerty does, he actually sits on Slack. He's a bot in Slack. Slack is where our alerts jump. So every time we get an alert on Slack, Alerty comes into action and creates a button for resending the results, meaning that every time we get an alert on a failed message, Alerty creates a button saying resend, and then you're in the context of the alert. You don't need even to copy paste a message ID. You just press the button and it resends it. This is great. Everybody was super happy about it. Just mind you, Alerty didn't really win the hackathon. I mean, alerts in production aren't something that's very attractive, but he was up and running in production 3 or 4 weeks, short 3 or 4 weeks after the hackathon, and we were super proud about it. So now on call was much easier. Everybody was just racing to push the button. Everybody loves pushing buttons. So every time an alert jumped, all of us were racing each other to see who would push the button first. It became very, very easy, and it became somewhat of a game. Okay, so I'd like to stop and talk about an important point here. We're talking about debugging black boxes. When we debug black boxes, the main thing is to gain control. I want the most control in my hands on my side, and I don't want to be dependent on the black box. And what we did with the backdoors here is actually gain control over the retries. We had our own mechanism that we didn't care if mesh was up or down. We could send the messages again and control the retries. So let's get back to our story. We were pressing buttons, we were happy, everything was going really easily. And then we got to our famous oh moment. Okay, so actually what's going on here? I mean, we had our retry mechanism, everything was fine. Why did we have 80 messages that weren't sent? Well, you remember I told you that the mesh server was down for a bit and then came up. And actually, when we were receiving these 500 status messages, we were so busy pushing the button that we actually resent it very frequently, meaning a very short time after the actual message was sent. And our monitoring tool, apparently it had some kind of configuration that if the same error message comes within 5 minutes with the same ID and the same everything, and the second time it wouldn't shout out saying that there's an alert. It would be silent, meaning that we were super dependent on our monitoring tool. And we were so busy pressing the buttons that we were sending the messages so quickly that our monitoring tool wasn't shouting about the 500 again. So this is a problem. We don't want to be dependent on our monitoring tool. We want to know about the failures in our data and in other systems. This leads me to our next tool. Databases today have very deep pockets. Let's just save everything in the database. We want to have the exact indication of everything that's happening in our database, and we actually want the data to be immutable. If we think about our 80 messages that we couldn't find, the 80 failures, this is what we were looking at. We were looking at logs in order to understand what messages failed. I don't want to be looking at logs. I don't want to be uncertain. I want to have the certainty, and I want to have the information, the actual information right in front of me. And that's why I want the information in the database, meaning that I would like lines in the database per each message with its unique identifier. I want to know if it failed or if it succeeded with a timestamp. And actually, I want to build more than that. I want the data to be immutable, meaning that if I try to send a message 3 times and it failed, and in the 4th time it succeeded, I want all of this data in the database so that I know when the message failed and when it succeeded. And then I don't have to ask the black box anything. I just know exactly what happened with my message. Now we're bulletproof. We can actually create some kind of job that will run every day or every hour, whatever we decide, that will go into the database and collect all of our errors. When it collects the errors, it will resend the messages on its own and then update the database again. And now we don't even need Alerty or any buttons. We just have this job, and we have an asynchronous mechanism for resending failed messages. Okay, so maybe this time we can actually go to the beach. Well, we all know what happens every time we even think of going to the beach. Oh man, how can we be in this situation again? We were still pretty anxious from the last time. And because we were so anxious, we didn't wait for the clinic to call us up. We actually proactively called the clinic 2 or 3 times a week to make sure that our results were streamlining as we thought they should be. So what happened this time? How can we be in this situation again? Well, you remember I told you about the mesh and the mailboxes. This is an asynchronous operation, meaning that when I send a message into mesh, the receiver app, the NHS client, has a pooling mechanism, and it pulls the messages every half an hour or every 45 minutes, meaning that there can be 30 or 45 minutes between the time that I sent my message and the time that the clinic received it. So how can I actually know that the clinic actually received the results, received my message? Turns out Mesh has an ACK mechanism. Every time, once the clinic receives my message, it sends back an ACK message to the Mesh server saying, I received this message. Great. We want these ACK messages. Mind you, I'd like to say, of course we knew about these ACKs while we were developing the mechanism to begin with. But we were so busy trying to get in, we were like, let's deal with the ACKs later. Well, later is now. I want these acts and I want them now. I want to have the certainty that my message reached its destination. So I think you can all guess where these acts were actually sitting. You remember the client that we got rid of before? Well, of course, the mesh acts were sitting inside this client. So we brought up this client again, and now we were in the same situation that I was talking about a few minutes ago. We're up and running in production, and we don't have time to start working on a fancy mechanism that will get the acts and save them into the database. We need to get these acts now because we want to know if our messages were received now. Of course, we will build a mechanism later on, but also here we had to split our efforts. First of all, get the acts and start looking at them, and offline we would create a mechanism that would save them into the database. So a little bit of monitoring 101, we SSH'd into the client, we grabbed the errors, and we had the errors in our hands. Great, so now we have the error in our hands. We looked at the errors, and actually we were disappointed to see that we had no way to connect between the ACK message and the actual message we sent out. This leads me to our next tool. It's super important to speak the same language as your partners, meaning that I want to have an ID of a message that Mesh also knows about. And this is actually something that was quite easy to implement. We realized that we could send a Mesh message with an ID that we created into Mesh, and Mesh would record this ID and actually send us back the ACK with this ID. And that way we could connect between the ACK and the message. Great. So now we could actually have the full cycle of the message in our database. We know when we sent out the message, we know when the mesh server received it, and we know when the clinic received it and whether it was successful or maybe had an error. We have the whole life cycle of the message with timestamps, and we really have the full picture here. We can also log and persist the errors. If we have an error of some kind of message, we can save it into our database. We have an errors table, and we have the actual data of the error. And now we can really understand not only if there was an error, but what actually happened with the error. I'd like to stop and mention another very important point here. So we were talking about gaining control over the black box. By saving all of this immutable data in a database and having shared IDs, we had full control over the data. We no longer had to ask the black box, did you receive this message? Was it failed? Was it errored? We have all of this data in the database, and we fully control the flow and the data. So this is great. We got the errors, we saved them into the database, and we had all of the information that we needed. Now, if we get an error, we can open up the message and try and understand what the problem is. Here we had kind of a problem. When we opened up the error, this is what we saw. Again, very hard to read, right? What are we supposed to do with something like this? Okay, of course, if we look closer, we can see a timestamp and we can see some kind of string that elaborates the problem. But hey, I don't know what this means and I don't know how to solve it. And I can't be flying to England every time I have an error to knock on the NHS clinic doors and try and find out what's going on. I have to solve this from Israel, and I have a lot of backend developers that are spending most of their time trying to figure out what went wrong with Mesh instead of developing new features. So this leads me to my final tool, engaging the field teams. The field teams aren't developers, but they are tech savvy, and they do have the connection to the NHS clinics and to the people working in the NHS clinics. For them, it's much easier to pick up the phone or go down to the NHS clinic and sit with the people and try and understand what this error is and how to solve it. This means that if I will create some kind of dashboard or tool that visualizes the errors for our field team, shows them the elaboration, what exactly was the error, and even gives them the option to resolve it afterwards, I'm giving them the control over the flow, and they can do all of the work where my devs can keep on developing features. This makes a lot of sense. So this is also an important point. Giving the team in the UK, our field teams, these dashboards gives them control over the flow and gives us control over the flow and over the black box. And again, I'm not dependent on the black box. I have full control on my side. So we're still not there, right? We're still not sitting on the beach sipping mojitos every day. But we're pretty close to it. For whoever's concerned, it's been over a year since we established the integration, and we've served over 80,000 patients that we brought healthcare into their home and hopefully made their lives better. So things are looking good. Let's recap our tools from today. So the first 5 tools were to do with cracking into black boxes. Now, debugging black boxes, which is a much bigger challenge, included building the backdoors in order for us to have control over the retries. Sorry, and then we had immutable data and shared IDs, which gave us control over that data. And last but not least, tooling for the field teams that give us control over the flow. Thank you very much. I hope you enjoyed and learned something new. And next time you're facing this 3-headed black box integration, you can just pull out our toolbox and start hacking. I'm available for any questions. You can approach me via my email. Thank you, everyone. Goodbye.